Alright, ladies and gentlemen, we meet again once again. So I want us to look at chapter 3 of Engineering Graphics and Design grade 11, chapter 3 of Engineering Graphics and Design under the topic of isometric task 4. This is chapter 3, grade 11, Engineering Graphics and Design task 4. So this is the given information, given a question. So this is a given information. So it read as follows: the given figure shows the front view, top view, and the left view. Shows the front view, top view, and the left view of a model in third angle orthographic projection. So as far as I am concerned, I think they was, instead of saying left, they were supposed to say right, because they further go on and be telling you what they are given in third angle orthographic projection. So under third angle orthographic projection, we do not talk about the word left. We are having a right view according to third angle orthographic projection. And again, if we go to our figures, we are the what to call the symbol. This is the symbol of third angle orthographic projection. So indeed it it correspond and confirm that they are given in third angle orthographic projection, not in first angle orthographic projection. So use the given information and make a neat isometric drawing of the model to a scale 2:1. So this is the enlargement scale of 2:1. So you must know what is the meaning of that. We are having 3 different types of scale, unless they are saying you create a suitable isometric scale. But in this one, they are saying 2:1, which means we are going to multiply every dimension by what? By 2. So where applicable, the necessary lines as necessary center lines, constructional lines, and auxiliary views must be shown. No hidden details is required. Make a corner A the lowest point of the drawing. You understand? So in other words, they are saying point A, it must be the lowest point. So from there we have to come to the views then. So this is going to be my front view, this is going to be my right view, not the left view, my right view, not the left view. So this one is going to be the top view. Are we together? So now let's start. So you know your starting point. I will draw the horizontal faint line. Then from there, I will draw a one that is perpendicular against it. So where they're saying let point A to be your lowest point, that point A that they are talking about, it should be this one. To me, it should be that one. So which means I do not have to get any point less than that one. So from point A, I'm going to open 30 degrees in an anti-clockwise, in a clockwise direction, 30 degrees clockwise direction out of dimension. So 30 degrees anti-clockwise direction. So you draw these lines faint, so they have to be faint, my brother. So from there, what am I going to do? So at point A, that's where I'm going to start. At point A, that's where I'm going to start. So I have to force myself to have a shape, this shape way at this direction. This is the right view. This is the what? This is the front view. You understand? So at this portion, I have to get this shape. You understand? And then at this portion, I have to get this shape. You understand? So from here, I'll start with the what? With the height. The height, we are told from here till here is 5 millimeter. From here till here is 5 millimeter. And the 5 millimeter is where is being dimensioned for you there by your what? Your front view. The 5 millimeter. But then you are going to remember it's a enlargement scale. So it's 5 millimeter. So it's going to be 5 times 2, which is 10 millimeter, isn't it? So which means I can measure the 10 millimeter from here till there. There is another 10 till there. You understand? There is another 10, which is this one, from here till there, from there till there. Then after I've gotten that, I can draw it dark, which means it's this one from there till there. It's dark from here till there, and it's going how? Vertical, from here to where the second 10 ends, isn't it? So I can draw this line dark without clear. You understand? So from there, I'll take the very first 10 at an angle of 30 degrees anti-clock, as well as this one, as well as this one. There you go, faint. There you go, faint. Right. So there. Now let me see what is going to happen now. So I have the set from here till here is what? Is 20, is 5 millimeter. From there till there is 10, while from here till there is 20. You understand? So I can simply, 20 times 2 is going to be 40, isn't it? So from here till there is that 40 millimeter, which is from here till the 20 times 2 is going to be 40. Whereas from here till here is 5, which means it's going to be 10 and 10. So from here, this is not 40, this is 45, my brother. Be careful. So it's what is 20 times 2 is going to be 40. So the true 40 is here. So the 5, which is 10 now, and the 5, 10, which is 10. So from here till there I can have it dark and dark. You understand? And I'm going to go up dark here, go up dark here, go up dark till up there on this one. You understand? Which one is this? So I want to get a shape that is like this, isn't it? A shape that is like this. So now you can have this one dark from here till right there. You understand? And I can have this one dark as well, as much as I can see it right here. Okay, yeah, indeed it's dark. You understand? So let me approach to draw the right view now. So at this point, so I'll come to this side, this right from here till there's 20, so which means it's going to be 40, and 20. You understand? So the very first 20, which is 40, isn't it? And the second 20, which is 40. Then the last 10, which is going to be how much? Is going to be 20, because it's 10, isn't it? It's 20. So the first 20, what is it giving me? It's giving me that one. The second 20 is giving me that one, and the last 10 is giving me that one. And check there, A, B, C, D is what? It's a half of a hexagon. So it's a half of a hexagon. Do you see what this shape is? The shape of a hexagon. It's the shape of a hexagon. So we have to start with it, you understand? So from there, so this one is dark, so I can have this one dark, and come back to have this one dark as well, which is the base of my right view. So actually it's not supposed to exit, it's supposed to end there, but then since I'm teaching you, so now do you see that the vertical center of your hexagon is actually in the center of what? Of the second 20. You understand? So which means let's get to the vertical center here. So the half of the second 20 is what? Isn't it 40? So it's going to be 20 according to the scale of enlargement. Then from there, means I can have this one put the vertical center line. For now. Right. Then from there, let me see I'll have to go straight to draw the hexagon. I have to go straight to draw the auxiliary hexagon. So the auxiliary hexagon is how much? It's 20, isn't it? So which means it's going to be 40. It's going to be 40. So I'll simply open my drawing, take my drawing compass and open it to 40. Diameter 40. So we know the properties of a hexagon. All the sides, they must be equal, and it has got how much? It has got 6 corners. So if from here B, remember BC is the same as CD, is the same as BA, isn't it? So that's the properties of the hexagon. So if they're saying the distance of BC is 20, which means again from here till here is 20, So but now remember is the 20 times 2, which is the enlargement scale, isn't it? So which is giving you 40. So take your drawing compass, open it to 40. I felt like I didn't explain that one thoroughly, which is 40, isn't it? So now I'll try to have it way this side. It's going to fit here. So I draw the faint diameter, cycle diameter, diameter 80. I want to have a hexagon of 40. So this is diameter 8. So where was I placing my drawing compass? Right there. So I'm going to put the horizontal center line as well as the vertical center line. Like this. So from there I can take my drawing compass and place it at this, because I want to have because we have 2 different types of hexagon, isn't it? We've got across the flat and the flat hexagon. So in this case we want the flat hexagon. So we are going to use the horizontal center, place the drawing compass at this point along the circumferences of your cycle and open it to the center, then strike an arc, I come to the second one opposite, then I strike an arc there. Then from there I'll join these points that are along your circumferences of the cycle. I join this one, there you go, join this one to where you are placing your drawing compass, isn't it? Then other one, just that one, and from there you go, from there you go. So how many corners do I have? 1, 2, 3, 4, 5, 6, which is 6 corners. So if right from the given question being a dimension like this, so this A, it will be as good as if it's this one. So this B, it will be this one. This C, it will be right there. This D, it will be right there. So A, B, C, D, you understand? So that's how we go about it. So now we'll be recording dimension from here and we'll put them right here. So double check your right view that this hexagon of yours is actually sitting where along this line of what, of 20, of 10, of 20. Remember from here till here is what, is 10, is 20, isn't it? Because it's 10, that gives you 20. So line BC is actually lying along the what, the line of 20, which is this one. So that gives us a leeway, that gives us good, okay, this thing is simple, straightforward, isn't it? So now if I have this auxiliary of mine, that point that one where the horizontal center line and the vertical center line, they are perpendicular to each other. I'm going to name that point R. I'm going to name that point R, which means is the reference of all the points that I've just got, isn't it? Of all the points that I've just got. So this is the auxiliary. So now I'll be recording dimension from here till here. So if we go back to our right view, BC, the set is how much? It's 40, because it's 20 times 2, isn't it? That gives us 40. So that BC is what we already have here. So which means I can say my B is now right there and the C is right there. You understand? And BC, it is actually not solid. There is no any line that is connecting there. There is no any solid or dark line, you understand? So I cannot draw this one dark as well. But now what I've gotten is this point. From here till here, I've already gotten it. It's already came out by itself. That very last 10 millimeter times 2, you understand? I've already gotten it. How about this one? How about this one? So this one, it seems to be in the center of what? Of this 20, but we cannot assume that unless up until we prove it, indeed is actually at the center of what? Of 20 millimeter. At this moment, let's get what? Point R, which is that one. How do we go about it? We know what point R is actually along this vertical center line, and as we already have BC, which is BC, you understand. So simply take your drawing compass, place it at point R, there by your auxiliary view, R to this horizontal, to this line of what? Of CB, which is this one, right? So now I'll come and place it here and just get a mark. So there, that one is now my point R. You understand? So what do I have there by point R? I have what? A line that is actually at an angle of 30 degrees anti-clockwise, which is the center. You understand? So I'll further extend this one just a little bit. This is interesting. You understand? So now, assuming this one right from the given view, it was solid, like as I've said before, BC, assuming it was solid, by now we would have drew this one solid. You understand? And remember, our hexagon is half. You understand? We are not going to draw it a full, right, like the way we have just drew in our auxiliary. It's a full flat hexagon, but when you now put it into a model, it's not going to be. So now go back, take your drawing compass, go back to your auxiliary view, simply place it there by your R, where the vertical and the horizontal, they are perpendicular to each other. Open it to point D. Point D is expected to be the same as point A. Indeed, is the same. So which means from R to A is the same as R to D, isn't it? So now I come to my drawing and put it at R. I want to look, I'm actually looking for point D this side and point A this other side, isn't it? So I am already having A there and a D right there. You understand? So what do I see right from the given view? Okay, I see a line solid from from B to A, isn't it? Get that using what now? Your 30 millimeter ruler. From here till there is solid now. And I see another one which is CD, isn't it? So do the same thing, which now I'll be using my 30 millimeter ruler from here till there you go. You understand? So this is what I have. So right from point D, my brother, I see a vertical line going back to the line of what? Of CB. You understand? Which is out of dimension. But for the fact that we've gotten this one, so this one, it will automatically come out by itself. How? So I'll simply go like this now. But now from here till there is going to be solid. You understand? So again, this one solid. You understand? So now let's see what this distance, even if you don't want to prove that, it's not a problem. We just want to see what is this line at the center of what, of that 20. Now 20 times 2 indeed is at the center. You understand? Indeed is at the center. Because from here till there is 40, which means from here till there, you understand? We've just proven it. Okay, so now we can then argue to say indeed this one is at the center. We've just proved it, isn't it? So from there, what are we expected to do? So now we are going to go how? Do you see that a line AB? Let me emphasize that the point AD, they are actually in the center. They are actually parallel to each other. They are actually in the same line in terms of horizontal. If we can just join them like this, they'll be in the same line. You understand? As much as we see them clearly there by our auxiliary line point AD, they're actually in the same line. You understand? But if you check it nicely, this horizontal line or a point line of yours where we're supposed to get a radius of 10 millimeter, it's actually not in the same line as the line of AD. You understand? So that one, you'll go back, my brother. You are given the dimension. From here, check it nicely there by your right view. Your front view. Check it nicely there by your front view. You are given dimension of it. The set from here to the center is what? Is 20 millimeter. So which means from here going up is 20 millimeter, and you're going to say 20 times 2, which is giving you 40. So actually this one, it was the center of your hexagon. So now where is my 40 ending? 40 is actually ending right there. So it's just a little bit up. You understand it? You understand? So you have to be careful about that. You have to be very careful about that. So now how do you go about it? So after we've gotten this one, so I can simply which means this one I'm supposed to draw it just a little bit fainter than this one. You understand? So now from there, what do I have to do? So now I can do what? I can deal with with this radius 10. So it's going to be radius 10 times 2, isn't it? That's giving us radius 20, not diameter, radius 20. You understand? Radius 20. Okay, before that, let me see this line. You see, from A it goes up. From A it goes up. Okay, so I can go up here, vertically up, faint. Okay, now we said it's radius what? Is radius 20. Radius 20. So I simply open my drawing compass to radius 20. So now I will come to say this is R, isn't it? Let me name this one R1. This is R, this is R1. So I'll simply place my drawing compass at point R1 and mark here and mark down here. I'm creating a square and mark to this one, not this of point R, but along the one of point R1, and mark even on this other one. So I have two points which I've just marked along the vertical center line. I've got 2 points which I've just marked along the line of R1, which is 1, 2. So from there I am going to create a square. So firstly, a faint line that's going to behave like this, that will just pass there. Let me give it a little bit of zoom. You understand? So from there, and another one that will go like this. There you go. Then from there, I am looking for a square, so I have to try to be accurate. So I am having my square already. So we know the properties of the square. All the sides, they are expected to be equal, and it must have 4 corners. So this is corner, this is a corner, this is a corner, this is a corner. You understand? So now I'll decide to name this one corner 1, this one corner 2, this one corner 3, this one corner 4. It's a square. It has got 4 corners. You understand? So between corner 1 and corner 2, I have a center, which is that one. Between corner 2 and corner 3, I have a center, which is that one. Between corner 3 and corner 4, I have a center, which is that one. Between corner 4 back to corner 1, I have a center. So the first center, that is between point 1 and point 2, I'm going to name it a small letter A, not a capital letter, because I am already having a capital letter there. So between point 2 and point 3, there is a center, which is a small letter B. Point 3 and point 4, there is a center, which is going to be center C. Between 4 and back to 1, there is a center is going to be center center D. You understand? So now the binary method is going to say join the 2 longest opposite corner, the 2 longest opposite number corner, and so which means we are going to join the number to a number. You understand? So point 1 and point 3, they are opposite to each other, long enough compared to to point 4 and point 2. Point 4 and point 2, of course, they're opposite to each other, but not as long as compared to point 1 and point 4 are together. So now what am I going to do? Take your drawing canvas, join point 1 with point 3. I am trying to be fast. Actually, I'm supposed to be. And when you are joining these 2 points, it has to pass exactly point R1, like this one of mine. You understand? So now you're going to join a center point to a number point, and a number point to a center point. You are going to join a center point to a number point to a center point. And now we are joining a small alphabet to a number, a small alphabet to a number to a small alphabet, which is, and these 2 lines, they must be parallel to each other. We said we are joining a center to corner to center. So let's go. Faint, isn't it? This one, there you go, and this one you go. So these 2 lines are parallel to each other. So the time we join a center point to a number, a corner to a center. So we got, this line was cutted. This one is going to be Roman figure 1. This one is going to be Roman figure 2. So it's always necessary to number your points. You understand? So the moment you number your points, your work is actually becomes simple. So you won't be saying, no, I'm talking about that point, I'm talking about that point. You'll be calling them by their names, isn't it? So now remember that we are not looking for a full cycle. We are just looking for this bottom one, this one, this smaller one, isn't it? So now take your drawing compass, put it at what? At point Roman figure 1. Further extend it to what? To point A, and you must get an arc that will start from point A to point D. So this is Roman figure 1 to A. So before I draw, I check. So now I can draw. There you go. I can draw it dark now. There you go. You understand? So which means in our portion, we've already gotten this one. We've already gotten this one. Which one? This one. We've already gotten this one. You understand? So now we're looking for this one. You understand? So how do you go about it? So now you're going to place your I must get an arc that will start from C to D. So we're going to use point 2. So place your drawing compass at point 2, further extend it to point C. This is it. So draw dark. There you go. Dark. You understand? just like this. So which means we've already gotten one.